Good morning, ladies and gentlemen. Thank you very much for coming back for our session today, which is talking about will bifacial BC be the next big thing? Today, it is the focus on bifacial and BC, and the highlight has been on BC in the websites and articles of Taiyang News. So today's session, we're delighted to welcome Germin from Taiyang News, who's going to moderate our session discussion. Some of the discussion will be in Chinese and some will be in English, so of course just keep your headset on for that. Before we get underway, I'd just like to introduce our panel today. Of course, we have Dr. Yongqian Wang from AIKO, Chris Xu, or Xixiang Xu from LONGi, Chief Scientist of LONGi, Dr. Radovan that we've met earlier, and of course we're delighted to have Dr. Guangqi from Maxeon. Let's welcome them and enjoy the discussion.
So let's start now. So it is a great honor for Taiyang News to be invited at this time to moderate this panel here. Okay, so we have today so 4 really BC experts here at the panel. So let's take a deep dive into BC technology first. Let's talk about first the evolution of the BC technology. Dr. Wang Yongqian and Dr. Xixiang, we know that AIKO and LONGi have started working on BC technology many years ago. And during this time, it was still not clear which technology would sustain the perk. But the key contenders were TOPCon and AJT. So what really attract you to bid on BC? So first, Dr. Wang, please.
我们选择 BC 技术其实呢不是偶然的，晶硅的技术路线呢其实是很清晰的。BC 呢它代表着单节晶硅电池最终极的版本，从 POC 到 BC 呢中间还有一些过渡性的技术。那我们呢经过多年的调研啊、探讨，还有一些试验的一些验证工作 ，BC 技术呢虽然是很有难度，但是也并非是高不可攀。只要我们努力 ，BC 技术的产业化呢可以大大加速的。爱旭呢决定了就是投入主要力量，把晶硅作为主攻方向，一步到位的发展晶硅的这个技术。
Chris, please.
Hi. In LONGi, we have first principle thinking, and from that on, we believe BC technology enjoys highest conversion efficiency. So there are 3 factors for PV technology: higher efficiency, lower cost, and better reliability. We believe in all these 3 areas, there's a good potential. So as Chairman Chen mentioned, LONGi also independently initiated a BC project, and around 2016 and 2017. Actually, so far, LONGi has done almost BC technology in all areas, like P-type, that's HBBC, first generation, that's P-type. Now we have a second generation, it's N-type. We do have a low temperature one. We published their results on Nature. It's a 27.3% efficiency. That's all low temperature. Of course, you can imagine we have hybrid one between high temperature and low temperature. Yeah.
Okay. So my next question is to Radovan. So there have been several BC generations of different at ISC. So your first Zebra was without passivated contact, but now you also have adapted to passivated contacts. So what changed from them to now?
Yes, thank you for the question. So maybe to answer this question, you have to understand how ISC Konstanz was, let's say, working on N-type technologies. I already showed a first picture that we started to work on N-type already in 2005. And that was on NPERT, and we also worked with Bosch at that time, starting to develop IBC technologies. And at that time, passivating contacts were not ready. But we wanted to bring a low-cost version of IBC into the market, and we were experts on boron diffusion. So let's say going from NPERT towards IBC, having boron and phosphorus diffusion without having any passivating contacts was quite straightforward. But there was there were few challenges which are still challenges these days, which are, let's say, fast lasers to ablate the area of the solar cell. So it's the area is much higher, of course, than it used to be for selective emitters. But we achieved to develop the Zebra solar cell already in 2018, which we commercialized with SPIC, having an efficiency above 23%, which was okay for that time, like having voltages of 705 millivolt. But of course, at that time we were competing with PERC. Now when you compete with TOPCon, it's not possible anymore to have this technology existing on the market. So we started 5 years ago also to develop, of course, a technology with passivating contacts. We call it PolyZebra, and then efficiencies of 25 plus can be achieved also in very low-cost way. And maybe to say one more thing, our specialty at ISC Konstanz is still screen printing. So we have a special screen printing method, which will be also shown in the presentations this afternoon. And we still think that in screen printing, it's a huge potential. So our next generation will be TOPCon back contact with screen printing technology and copper.
What is the targeted efficiency?
The targeted efficiency in a European project is 25.5%. But of course, improving the material, improving the process, and we can go above 26%, like AIKO is already showing.
Yeah. Okay, so the next question is to Dr. Guangqi from Maxeon. We all know that SunPower Maxeon has been the pioneer in BC field. So what were the key milestones in the development of your IBC technology until today?
Okay, so thanks for having us. So in SunPower, yes, we did have a long history in developing BC cells, and it's almost 40 years actually. And regardless of SunPower or Maxeon, we managed to land the 11 world record champion cell efficiency on the Unreal top efficiencies solar cell chart. Each of them are unique in my way, but if I have to pick up few highlights, I would say the first one would probably be in 2004, where we made the first commercially available BC cells, which is 20% in efficiency. Next one would probably in 2007, where we first bring in the laser patterning method into BC fabrication, and we start the contact passivating BC cell in 2008, and that brings our cell efficiency over 23% at that time. And throughout the years, Maxeon team continue work on this area, and in 2015, we managed to bring the TBC cell efficiency to go beyond 25%. And we're still doing effort to making this number even higher. I think that's for the solar cell technology itself. For the modules technology, there are several highlights as well. For instance, in 2004, we were the first one to report PID effect, and we started work on encapsulation method to counter this effect. And in 2012, if I remember correctly, so that's where we bring in the anti-reflection coated glass using porous silicon dioxide, which is pretty much the standard in the industry later on. And in 2013, if I'm not wrong, then we actually bring in POE as a standard encapsulation in our products. So yes, it was a glorious history, but like any high-tech company, we should always focus on the future to bring more value to our customers and to this industry as well. Thank you.
Thank you. Okay, so we know that BC as a biocontact technology has a very high efficiency potential. So let's then talk about a little bit about the technologies. This question, I have the question for all. What are the inherent advantage of BC over the other mainstream technologies such as TOPCon and HJT at the end product level? So, Dr. Wang, you first.
BC 电池呢，它有远高于 TOPCon 或者是 SJT 这样的这个电池效率，同时它的美观度作为一个平台技术呢，它可以叠加更多的一些新的提效的手段，还有它就是有一个其他技术所不具备的高阴影啊、高热斑啊，热斑的话也会引起这个短路啊损坏，所以这一方面它比较安全。而且这个组件方面呢，可以做满屏，其他的电池技术呢不太容易做到满屏。所以 BC 技术我认为是一个最完美的电池技术。它从全面受光呀，还有这个全机动画呀，还有它金属化。金属化方面呢，可以更适合于简单的金属化，就是它单面印刷，或者是单面的涂布啊，或者是电镀来做这个金属化。所以它很多的这个性能优势和制造优势。
Yeah, Chris.
Okay, yeah, I totally agree with Dr. Wang Yongqian. I think he has given a very thorough answer for that. On one thing, I like to add a little bit more detail. For example, by roughly about mid-2030, and the PV need to have an annual delivery of roughly about 3,000 gigawatts. So sustainability, I think, is a big issue for this industry. And the BC has advantage on that. For example, like a silver, like indium. I just give one example. LONGi has been working on 3 non-silver metallization. Yeah, one is open, it's a copper plating, yeah. And the other 2, I just give one example. We can use a vacuum technology to deposit the metal thin films. You can use, say, thermal evaporation, different type of evaporation, even magnetron sputtering. And you can use aluminum, you can use copper, non-silver, this kind of precious metals. And we started working on that on the front and backside FBC heterojunction. So you can imagine, you need to have metal grids on front side, also backside. But with BC, you don't need a front side. For front side, you need to have a grid width very narrow and high. So you can imagine for vacuum deposition, that means a longer machine. So I think you can get idea here. And metallization, we really have advantage on that. And of course, we have something else. I think roughly in probably half year, less than 6 months, we should have a non-silver metallization for LONGi's BC technology.
So the inherent advantage of BC on the end product level is so you can use the non-silver metallization so that you reduce the cost. Okay. Yeah. So Radovan?
Yes, so many things have been already said, but I can add to this. Yes, exactly. This is also the major advantage that we are seeing is the copper screen printing technology that, of course, you don't have to be, let's say, the fingers, you don't have to print too shallow. You are somehow cannibalizing a little bit the bifacial factor, but still the sun comes from the front side. So the front side is much more important. So implementing new metals into the device, the IBC solar cell is much more valuable. In addition, it has been already mentioned, the negative gap technology is much easier to use in IBC solar cells. There will be a presentation from our group on this technology. We have a patent pending on that with IBC solar cells. In addition, I would also add, if you are a 4-terminal tandem fan, then IBC technology is a perfect match. Because if you want to make it also bifacial, the emitter is on the rear side, which means that you benefit much more from the infrared. light or from the albedo from the rear side. In addition, you don't have to make any position matching of the top cell and the bottom cell because you don't have any contacts on the front side. So for 4-terminal tandem cells, IBC technology is the perfect match. And I'm a big believer of 4-terminal because it's very simple. You more or less put a power booster on top of your. It's not that simple, but it's the simplest way for me to make a very quick tandem solar cell. We are working on this with First Solar, and they are also convinced IBC is the perfect match for 4-terminal.
Yeah, and Dr. Xu?
Okay, so we choose BC mainly for 3 points at least. So first one, we think if you choose metallization method wisely, you can very well end up with a similar or comparable cost structure as TOPCon. But because you're doing a BC cell, so inherently you'll get at least 1% to 1.5% absolute higher efficiency. So that's extra value. And another thing is when you put two polarities on the same side, it opens opportunity for different kind of metallization schemes. And that will bring in additional reliability enhancement, which is a big plus if you want to deliver those products to higher-end markets. And last one is the aesthetic advantage. Some customers, they do appreciate a black module. Thank you.
Okay, so the full black module in the front side is the advantage.
Yeah, some people, they do prefer that
Okay.
on their rooftop.
Okay, yeah. So we just discussed about the advantage, right? Then also the question for all panelists, what are the fundamental and particular barriers for the BC technologies?
应该说，主要的障碍已经就是解决了。BC 技术呢，从第一次提出到现在已经有半个世纪了。之所以在前些年没有真正量产起来，是有很多的技术问题。最近几年，我们中国的光伏企业参与进来呢，很快的把这些技术问题都攻克了。比方说它的结构图形化、金属化，还有就是我们怎么样把它做到大硅片，做的很大的这个产能，这方面都解决了。那目前来说，它跟 TOPCon 和 IJT 比呢，起步稍微晚了一点，但是它有后发优势。再往前发展的话，进一步的降低成本，扩大规模，还有就是在这个集中式这个场景下呢，要进一步的提高双面率。这样的话呢 ，BC 它就能够全面的得到应用，并且呢，在所有的应用场景下获得优势。
Chris?
I think complexity of the process potentially is one of the factor, and not like since you have patterning there, your process is kind of like a pseudo semiconductor process. So it may take a little bit of time to optimize, to twin that one. I think people used to say that bifaciality is a weak point for BC technology. Right now, if can be within 5%, it's really no big deal. Say if HJT, TOPCon, you can get 90% or 85%. If BC is only like 3 to 5% lower, I think that's not a big issue. I think another potential issue is CapEx. At least for heterojunction BC technology, the CapEx, I think is still higher, for example, compared with the TOPCon, with PERC. Yeah. But I think there's some new ideas, and we are also collaborating with some equipment suppliers, getting there, getting better, but I think still, for time being right now, it's still an issue.
Yes, I completely agree with my previous speakers. So when we were talking 10 years ago with customers why that should go to IBC technology, there were many worries, not only on cell level, but also on module level, how to interconnect. There's a big Boeing and things like that. So there were, let's say, 10 problems unsolved. At the moment, I would say I will completely agree. Almost everything is solved, but we have to optimize. And so if you, for example, look how TOPCon came from PERC, or how the switch was done, there were also some technological issues. For example, P-type, N-type polysilicon was not ready, and people were using LPCVD. Now there is also PCVD, so let's say, the polysilicon for phosphorus doped, it's already well optimized. What we are still missing is, for example, the boron doped polysilicon, which many companies are working on. And so this is one thing, that if this will be, let's say, better developed, then also the capex will reduce. And other things that were not ready in the past, I already mentioned it, is fast selective processes like laser technology. And laser technology is a very important component for low cost IBC tech. That's why we will have also a talk from DR Laser tomorrow, how this technology is being developed in future. And the only issue I see at the moment is, as was mentioned already by Chris, get the capex down and also work on process optimization, improve the bifacial factor. But this is what we will see in future, that we will, with the bifacial factor, go very close to TOPCon performance.
Dr. Wang?
Okay, so in our view, we're thinking the early development of a PC, let's say a cell fab, there may be some special requirement on certain process or tool need to be established independently. And there are a lot of technical know-how in terms of cell structure, cell process, which could be a barrier for the newcomers. And especially for some of the cell features, you may have to change it after you have the field data showing something must be changed. So lots of things will add up some barrier for the newcomers, in my view.
Okay. Yeah. So we just discussed about the efficiency, about the technology. So for commercialized product, so okay, efficiency is very important. And other side, the reliability and the durability is also very important if you want to put in a product, a commercialized product on the market. So each cell technology has a unique degradation characteristic. So for example, UVID has been well known for HJT, and the topic now also pop up for TOPCon. So there are also different PID mechanism. So my question is for Dr. Xu from Maxeon. So Maxeon has the longest experience with BC. Have you noticed any different degradation behavior of BC compared to the degradation phenomenon of other mainstream technologies? So along with your BC journey.
Okay. So in our development history, we did see all kind of degradation phenomena, such as UVID, PID, and some microquark things. It's mainly come from two things. It's either cell structure or the bomb selection. So, but fortunately, since we are a head starter in this area, so we had plenty time to solve this. And through the effort of our team, we managed to solve those issues one by one. So now it's okay.
Okay. Yeah, so Radovan, so as a researcher, so have you made any special reliability study with your Zebra technology, and can you share any results?
Yes, so let's say we are researcher, but of course we have commercialized the Zebra technology with SPIC, so of course we have done very many stability testing, also PID and UV degradation, and also independent labs actually did a lot of studies on our bifacial Zebra cell. For example, there's a nice presentation from NREL looking at UV degradation and shows actually that the Zebra is UV stable, and that's because of the combination of diffusion and the passivation on the front side. You can make it really UV stable when, let's say, these two passivation possibilities are matched well. And we have done, of course, also many PID studies. And you mentioned it, SunPower already discovered in 2004 that there is a PID effect. I can still remember the title. It was "The cells are too good for the modules." And this was true. And with the implementation of polyolefin and good encapsulants, this is not a problem anymore. So actually, if you have a good double glass module with polyolefin or let's say polyolefin covered EVA, so there are some possibilities, and you are controlling the UV stability, and of course also you don't have any aluminum silver contacts, but let's say still copper or silver contacts. It's a perfect non-degrading device.
Okay. Yeah, so Chris and Dr. Wang, so what is your comment on the reliability and durability of the BC cells? What is the advantage here, especially for the durability? Yeah, Dr. Wang.
可靠性方面呢，我们也是做了2倍、3倍的这个 IEC 认证 ，BC 呢可靠性是没有问题的，甚至于会某些方面呢会比竞品呢要好很多，特别是导阴影啊，还有这个 UVID 啊，还有报衰 PID 啊，各方面都是比较好的。双面率呢是集中式电扇的重要的要求，客户有这个需求，我们就要往这块去努力。因为过去这个 BC 呢是一个小众技术，大部分用在屋顶上，给大家造成的印象好像是 BC 只能做单面。其实它是可以做双面的，可以把双面率做得很高。理论上呢，跟双面金属化的这个电池比较起来，可能在2-3个点的差距。所以说，我们是可以把 BC 呢做成双面的。我们在最近的几年吧，徒步工艺就是电镀的工艺，还是这个丝网的工艺，我们都在努力的提高。从我们5年前的30%几，现在已经提高到了70%，已经开始在G瓦级出货了。那接下来我们还在继续提升，提升的手段主要是背面的这开槽，还有就是我们的抛力解剖。这个呢是在 BC 也比较容易实现的。还有就是金属化的单线的变窄，这个也是可以通过2次印刷也好，通过极细的电镀的图形化工艺，我们是可以把它做得很窄。所以这个双面率问题呢，现在看来没有什么太大的障碍。结合前表面的这个高效，它的单瓦发电量呀是会比较有优势的。
Chris.
Yeah, I remember our chairman Zhong Baosheng said that if your efficiency is high enough, and you can afford to sacrifice some bifaciality. For example, the highest certified efficiency for TOPCon, there are two nearest numbers. One is 25.66% from Jingao, and another one is latest one is 25.9% from China, I believe. Yeah, so still a sub 26%. And we already announced 27.3% certified ones. Actually, we do have one higher than that. We haven't announced yet. So you can see, actually, there's a 1.5 point efficiency advantage of BC technology over non-BC. So that one is more like at least 30 to 50 or even a bit more watts over there. That's an advantage. And another one, just as Dr. Wang said, we can sacrifice probably 5 watts of this kind of high efficiency by boost up the bifaciality. Yeah. So our next goal is, near-term goal is 80%. So it's 80%, you have 85%, only 5% difference. And if our efficiency and modules, wattage is much higher, there's still advantage over there.
So the longest target for the bifaciality is the 80%.
Yeah, near term.
Okay. Radovan?
Yes. So our Zebra product at the very beginning, and I think we made the first bifacial IBC large module, which was also used for in the field. That had a bifacial factor already of 0.8. And but of course, if you are looking at bifacial factors, always the front side efficiency play a role. So our Zebra device, let's say, was not as efficient as the TOPCon back contact, and that's why the bifacial factors are also higher. So I think in the future we should also not only talk about bifacial factors, but maybe about rear side efficiency, because this is what matters. I mean, TOPCon can have a higher bifacial factor, but if the efficiency of TOPCon back contact is much higher, of course the bifacial factor will be also lowered. So that's the front side efficiency effect, of course. So let's say for Zebra, the bifacial factor was 0.8. And for our poly Zebra, you will see it in the presentations, we are at the moment at 0.7, but also having a strategy to go towards 0.8%. And but what I mentioned also before, let's say the most important thing is now also getting silver out of the IBC cell, also because of the OPEX. So it's not only the CAPEX that counts, but mostly the OPEX, and this can be done by copper contacts. And if you are slightly cannibalizing the bifacial factor by that, this would not matter actually. So we are quite sure that if we reach the highest efficiency for the front side, then the optimization of the bifaciality will play a role. But implementing copper will be also extremely important, also, let's say, with screen printing technologies.
So then, Dr. Wang, so what is your idea and Maxeon's idea about the bifacial BC technology?
Okay, so currently all the Maxeon products is monofacial. So this because our targets in DG market, that's the previous strategy. But BC doesn't have to be inherently to be a monofacial technology. It highly depends on the metallization method you choose. And there is an internal program within Maxeon aim to solve that. And from the estimation, 75% is at least guaranteed, maybe even higher.
Okay. Yeah. Chris, let me just add one question. So what is your actual opinion? So to raise the front side efficiency is more important than bifacial, or the bifaciality as actually important, more important than to raise the efficiency on the front side? So how to balance it? So Chris, yeah.
I think there's a variety of needs from a market and the customers. So you can have a different product aiming at a different market. For some case, if on the roof, you don't really need a bifaciality. But of course, you still have a lot of situations and you need bifaciality. And as I mentioned, we in LONGi, and we are developing a different product and serve for different market. Yeah, we can do both actually. As I said, with 80% bifaciality, if your power is not a 60 watt high, I'm talking about the standard, modules like 2.7 square meter. If TOPCon is say 630, and if we can do 680, 690, that one, we can sacrifice 5 watt. Basically, you can optimize the backside of contact, get a higher, different materials and narrow grades, this kind of things. You get a high bifaciality. It's doable. I don't think that's a gating item for BC technology anymore. Yeah.
Okay, thanks. Yeah, so then if we talk about the commercialized product, the cost is also very important. So if you want to sell the product on the market, but we know that BC needs more process steps, and of the process are more complex compared to what we are, the PV manufacturing used to. This gives the impression, like Chris and Rado also mentioned just now, so the CAPEX and the OPEX are relatively high. Can you comment on the CAPEX and OPEX of BC compared to TOPCon and AJT?
So I will talk about HBC. And for conventional heterojunction BC technology, excuse me, if you have a N area, N region, P region, and the front side, you use a low temperature parallel plate PCVD process. The CAPEX is too high. CAPEX is even higher than the HJT. So that one, I don't think in near future. We're working with some equipment suppliers doing something significant change over there, but it's not in very short term. So I would say for conventional heterojunction HBC, there's no capex too high. So that's why we're working on so-called, we don't have an official name for that, hybrid heterojunction BC. Yeah, maybe like H squared BC, that type of things. And we found the sweet spot. Capex-wise is not that high, but the BOM cost is much lower. The reason is, for example, like Indian, you do conventional HJT, you will use 110 nanometer front side and similar like that. But here we only have ITO on backside. You don't have to consider its arc effect. It's you don't need to worry about any optical effect that much. So we can go much thinner, particularly with bifaciality may sacrifice a little bit. And so naturally you can have 1/4 thickness of ITO. And also we develop technology, it's Indian free, no Indian. Efficiency is just a little bit lower. We believe we can do better over there. And the metallization I already mentioned, and we don't need to use any silver in this hybrid BC technology. So in that way, BOM cost is very competitive and capex just a little bit high.
But do you have a roadmap? So let's say that in the next 3 years, then we can lower the capex, or what is the roadmap in the future? So how fast you see to lower the capex?
I'm intrinsically optimistic because there is a hope in my name. Xi is hope. So I'm very positive to BC technology. I believe in 3 years, 5 years, this kind of time frame, BC will be a main working horse for the PV technology. Yeah. And we have a pilot line right now running. And I think actually we are getting a very positive results from that. And with close to 100% CTM, it's not like, CTM, 100% CTM, and we're getting the median batch efficiency is over 27%. So the module, you can think module wattage will be, as I mentioned, could be 50 watts or even higher than the current TOPCon technology. And cost-wise, I mentioned a couple of times, within 6 months, most likely, we'll have a non-silver metallization technology works. So in that way, cost-wise, is also very competitive. Yeah. So I'm very positive on PC technology.
Okay. Yeah. Then let's talk a little bit about the market potential and the adoption for the PC technologies, because any kind of commercialized product has to be sold on the market. Okay. So the question is to all, what do you see as the biggest barriers still for BC to be widely adopted in the market?
目前我们看下来，在分布式和在工商业的 BC 还是非常的受欢迎的。TOPCon电池呢确实过剩了，内结很严重。BC 呢相对来说是紧缺的，但是呢 BC 在这个集中式的高伏电站方面呢突破还不太多。这个主要就是我们要解决它的这个双面率的问题，还有低浮噪的问题。这方面呢还需要看到一些更多的数据吧。经过很多的这个测试点的比较啊，还有我们内部的研发呀。 我们发现，其实呢 ，BC 呢，并不是像外界宣扬的那样，它的这个低浮噪不行。低浮噪呢，理论上说是应该有优势的，因为 BC 呢，它的开压高，这个弱光性能好，而且它正面呢没有3线遮挡，太阳光斜入射的时候呢，它也没有这个阴影。综合下来的话，我们也自己也有示范这个案例。就目前情况下，我们这个双面率呢，比TOPCon差了这个8个点，但是我们最后算下来，它的低浮噪呢还是持平。 特别是在天气好一点的情况下呢，发电量会更高的。然后呢，就是目前的这个成本相对 TOPCon 稍微贵了几分钱，但是我相信呢，随着后面的半片技术、半片动画或者是满屏技术、零 BB 技术的导入，还有我们这大规模的非银的金属化，它的成本呢会很低，可以达到跟 TOPCon 在一起竞争集中式电站这个程度。尤其是我们这个 BC 的电池效率，它有很大的空间，跟 TOPCon 的拉开的差距呢会越来越明显，所以它的这个功率瓦数呢会很高，所以它没有理由说不能在这个集中式上使用，完全可以适用于各个场景，不仅仅是屋顶啊、工商业， 还有水面和电站都是可以用的。
Yeah, Chris, what is your idea about what is the biggest barrier for BC to be widely accepted on the market?
Yeah, I'm thinking actually overcapacity is a reality. So we can imagine next 3-5 years, there might be not enough, I think, newly added capacities. And I can imagine, we have a 500 gigawatt plus capacity for TOPCon, and probably gradually that may be upgraded to TBC. So when Dr. Wang was talking, I'm thinking, and transfer the HBC, even H squared BC probably will be a slow process. Yeah, I think that's a reality. Yeah, we need to digest that kind of overcapacity and let every PV company can make money so we can invest more. So I think there are some issues with reality, I think. That's why it's complicated.
Okay.
Yeah.
Rado?
Yes, so Chris, in your name is positive. Radost means happy. So I am the happy one, being with all the IBC giants here in this round, and to talk about bifaciality. And so let's say the final thing that IBC will really have a final breakthrough is bankability. And this has been always the case with bifacial products since the beginning. We were fighting since 2012 to make bifacial technology bankable. There were no bifacial simulation program. We were talking to PVsyst, please implement bifacial function, and they were saying, yeah, but there's no bifaciality on the market. So it was like a chicken and egg. And then, let's say, with the implementation of bifacial PERC, things changed because also of the volume of bifaciality, and so the bankability of bifacial systems came more and more into the market. And now, even if already now, let's say the bifacial TOPCon back contact or bifacial back contact solar cells have an advantage. You can calculate it with PVsyst, for example, at the moment for low albedo regions. This is definitely the case. Then still bankability is a problem, because let's say that the banks do not know IBC, and even if they are much better, they say, okay, but let's say TOPCon is now what people are doing, why we should go to. So it's a learning process. And as soon as you have, let's say, big megawatt, gigawatt bifacial TOPCon back contact utility scale installed, people start to get trustful and say, okay, so now we will invest more into bifacial TOPCon back contact. And I am proud to be here because this is now happening. I mean, AIKO and others, and I know mostly about AIKO, they are already installing bifacial back contact utility scale systems. So the bankability is improving at the moment. And I'm quite sure that and you have forecasted it, in 1 or 2, 3 years from now, similar things will happen, like that, like PERC switch to TOPCon. Now things will switch to back contact.
Okay, then Dr. Xu, so somehow also Maxeon has the longest experience for BC to provide BC modules on the markets. Rado also mentioned the bankability, so reliability issues. But what is, in the opinion from your side, what is the biggest barrier for BC to be widely adopted in the market, except the reliability, except the bankability?
Okay, so in Maxeon's view, we think the barrier probably lies in the scale. So BC is relatively small at this moment compared to TOPCon. So there's definitely more work to do in terms of further simplify cell process. Therefore, you can achieve comparable cost structure as TOPCon. And metallization is definitely one big issue. So I think we should move out of silver-based printing technology, looking for alternative metallization options. and for instance, copper or even aluminum. So, and the most important thing, based on Maxeon's experience or lessons, we think BC should start to establish its own ecosystem. That's the only way you can compete with TOPCon.
So your ecosystem means equipment and material, everything.
For instance, building an ecosystem meaning you have support from your upstream to the downstream. I'll give you an example. So take silicon, for example. So if you look at the silicon wafer spec for TOPCon and BC, actually, if you do a simple calculation, you'll find that BC actually has a lower standard compared to TOPCon. And that's because there's a unique feature in the BC cell process. So those sort of things, right now, they're just one point after another. But if you have an ecosystem, you can bring all these points together. Therefore, you can form a strong joint, and eventually you will win the battle with TOPCon.
Okay, thanks. So here's my last questions today. So according to ITI PV, so backcount will only increase its share from current 4% in 2024 to 15% in next 10 years. So do you agree? And when do you think BC will be the mainstream technology? So first, Dr. Wang, please.
国际光伏路线图呢，过去的这么多年的预测呢，都是偏保守，特别是没有考虑到中国的这个实际情况。我觉得到现在的话，对于 BC 的预测也还是非常保守的。我们自己也是跟同行一起讨论啊，就是预计啊 ，BC 呢可能在3-5年之内啊，达到这个产业规模上达到跟这个 TOPCon 这个相匹敌的这种程度。再往后可能就成为主流技术了，包括现有的 TOPCon 啊，看怎么去改造。所以说 BC 呢是终极技术，我们呢加速它，推动它早日的到来吧，把这个技术呢做到极致，这是我们的这个努力的目标。我们相信呢 BC 呢肯定是晶硅电池呢单节晶硅电池呢最终的一个标准的版本，在这个基础上，我们再叠加其他的技术，光伏对太阳光的转化效率进一步提升。
Chris, what is your opinion on the ITI PV estimation?
Yeah, I think, if you look at LONGi's history, LONGi pioneered monocrystalline silicon wafers. In the early days, actually, LONGi lost quite much money over there. At that time, it's a minority. But we put a lot of effort. We have an internal project like 616, we call 616 project. Yeah. It started on June 16. And within 3 years, actually, we brought the cost down more than what we expected. And right now, if you look at it, monocrystalline definitely is a mainstream of silicon technology. And we believe there's a similarity here between the BC and the FBC technologies. Yeah. I think I agree with Dr. Wang's prediction and evaluation. And as long as we can have a comparable bifaciality, if that difference, that delta is less than 5%, and also as Dr. Rita said, if we can optimize the process, have a better control on that, optimize that, simplify that, and make it more straightforward. Actually, if we look at the yield from a pilot line, it's pretty good. But we do have, I have to be honest, it does take us a little bit longer to do troubleshooting. We got issues and, we get like 0.3% lower efficiency. And troubleshooting-wise, it's a little bit more complicated. We're trying to do something better, since we do have people with expertise from the semiconductor IC industry. We try to implement some of those procedures from there. BKM, best known method over there. So I believe, so if talking about 3 years, I think those kinds of issues can be smoothed out. Yeah. So as I said, I'm positive.
Rado, do you believe that in 3 years, BC will be the dominated mainstream product on the market?
The short answer is yes. And so I like ITR PV very much. It's, let's say, it shows a good indication where the journey is going. But observing ITR PV since 25 or let's say 20 years, I don't know how long it exists, but for a long time I have always observed it's way too conservative on evolution, it's way too aggressive on revolution. So it's predicting a lot of new things, that tandem will be out there at 10% within 2 years. I don't believe that, because if you look, we will enter 1 terawatt market quite soon. I don't see tandem on multiple gigawatt because of bankability, because of different problems. So I see now that the switch from TOPCon to back contact will be similarly as it happened from PERC to TOPCon. Now the N-type technology for back contact is there, so we have to use it, and we have to go to the highest voltages, best front-side efficiency. This is how it always worked in PV. So yes, I think in 3 years from now we will have a switch. And what comes next is extremely difficult when tandem's technology will kick in. And from that point on, we will work, I believe, still a long time on decrease the OPEX and CAPEX and stay at very similar efficiencies, I think.
Dr. Wang?
Okay, so in Maxeon, we view this topic in 2 aspects. So one is that how aggressive BC could be in terms of efficiency, further improve efficiency. Now it's already good. Now it's already better. The other thing is we have to look at the global economy as well, because if the economy always stays in the deflation, like the bad market we're experiencing now, even the self-app won't have enough resource to invest in new technology, even if they want to. So, but in general, in our view, optimistically, we think 3 to 5 years is a well-educated guys for BC to be dominant.
So we agree that it still takes 3 years for BC to be a dominated product on technology on the market. Okay. 3 years. Okay. Yeah. Okay. So let's also take questions from the audience. Please raise your hands, and we can pick up 1 or 2 questions. Please, who has a question?
My friend Mehul, please.
Hi, I'm Mehul from RCD Solutions. Very nice points. Thanks a lot. So I have one question now is about, now like TOPCon, it's very common. Everybody's doing it. Every Tom, Dick and Harry is doing TOPCon. Yeah, let's put it that way. But now BC is very niche, and they are very, like they're champions, like masters of the art. So do you think it will become, as you predict, in 3 to 5 years, there'll be a big capacity of BC? But I think it's not that easy. Yeah? It's a niche technology. I don't think any Tom, Dick and Harry can start making IBC cells. Yeah. So what do you think about that? And also we have patent issues now, which is getting hot for TOPCon. And I think it'll also get hot for IBC in a couple of years. Yeah, possibly. Yeah. Thanks.
Yes, thank you, Mehul, for this question. So, yes, TOPCon technology, of course, we have multiple hundreds of gigawatt production out there. And let's say also in India now, this TOPCon technology from Adani, MV, they are picking up. As we discussed here, so let's say the modern back contact technology is very close to TOPCon. And let's say already now people are thinking how to upgrade their lines. And there are 2 ways how to do it. It's a double poly, so polysilicon on the front side, which is not easy. And so you have to have very selective processes. So I would agree. I mean, niche is some kind of word. It's a multi-gigawatt niche, I would say. And you mentioned patents, and in the TOPCon arena, this seems to be more a minefield than in a back contact, because back contact is already existing for a long time. So to my understanding, going from TOPCon to back contact, as we already discussed here, it's quite simple, and the patent situation is much easier than for TOPCon. There are JS Solar, First Solar out there, somehow also making a big noise. Oh, sorry.
Yeah, I think you did really well. I don't have much to add, actually.
Okay. And then we pick another question. Yep. I just hand over the microphone.
几位专家你好，我是国内做那个超快，就是皮秒、飞秒激光器的一个厂家啊，算是头部。一个是就是说，因为目前来说，在 BC 还好 ，TOPCon 的主流的激光器还是一个进口的激光器嘛，主要是进口的。那国产的激光器的一个对大家对国产激光器的未来的一个在光伏的应用的一个看法是什么样的？第二个问题就是说，关于因为我们皮秒激光器和飞秒激光都有那个绿光啊、紫外的一个就是差异嘛，波长的差异。大家认为可能未来是皮秒和飞秒哪个会占主流，或者是哪种类型的波长会更有优势？我主要这两个问题，好吧？
好的，我来回答一下。这个确实我们在做第一个工厂的时候用的是这个，我们是这个跟第二公司合作用的是国外的这个激光器，有这个飞秒的、皮秒的，还有压皮秒的。当然，这个激光的设备呢比较贵，这个一个 G 瓦呢，这个好几千万。但是现在呢，我们看就是国内这个跟踪的速度非常快，在这个国内做这个皮秒激光器的公司也非常多了。那我们也测试过好几家的这个激光设备，包括激光器。那我们总体看下来的话，主要有几点还是需要改进。一个是光束的这个稳定性，就光斑的均匀性，还有光束的指向性。这个不能跑，因为老是跑的话，这个你量产没法搞。所以说我们这个一个是要控制它的这个光斑的质量同时的功率呢还要再进一步的提升，因为我们这个做这个 poly 啊，它上面这个氧化物膜呢，它是比较难刻的，有个工艺窗口。所以它需要比较高的功率，我们国内有些这个激光是可以达得到的，那有些呢还是不够高，所以这方面呢，我觉得还要深入的去研究。另外就是我们怎么样还要把这个成本降下来，因为这个对于 BC 来说呢，激光是很大的一部分的成本。那 TOPCon 呢，现在呢基本上只有后面这个激光烧结有一点点，所以我们这块呢还是肯定是要走国产化的道路。这块呢就是大家一起努力嘛，一起努力，我觉得这个。我们是可以把它这个能够达到这个就是跟国外要的效果，或者比它更好。那我们从波长来看的话，它是这个基本是绿光和这个紫外没有红外在 BC 上面红外可能是用在组件上，可能焊接线盒是可以，这个是不需要这个多么高端的设备。基本上还有个成本问题，紫外的话可能要比绿光呢这个成本高一点，维护成本高一点。这个情况，谢谢。
Chris.
Yes, laser is a very important technology for BC type of solar cells, really. Yeah. And that's why it helps us a lot. But at the same time, there are also some issues. It's not only laser technology issues, it's integrated issues. Since you have like a thin film mask, and then maybe a thin film quality is not that uniform. Yeah. For example, it's it's not only thickness, it's optical, all kind of things. Performance is not that uniform. In order to deal with this kind of complicated issue, I think there's a more higher need for the laser. I think one point I like to make is I used to work in the Intel during good days, 20, 30 years ago. And even those years, I think equipment supplies, they built a very close relationship with like Intel, this kind of companies. And I remember in the Intel, there's a two R&D group. One group is, we call the D1, is in the Portland, Oregon. In the R&D part, actually, we even don't have equipment engineers. We have so-called module engineers. And you know something about need of equipment, and you're familiar, you're expert of a process. And the main portion of those equipment support was supplied by equipment owners. They have many people just staying with us, and we work together for the process development in order to get that kind of end process and what kind of performance equipment it need to have. I think that's probably also one way is, to do that. Yeah, we do have some equipment owners working with us closely, but it could be working closer. I think definitely, and as I said, laser is very, very important. Yeah, we use laser a lot in many steps, not only patterning. Yeah.
Dr. Xu, so what is the Maxeon's opinion on laser equipment for BC technology?
Actually, Maxeon doesn't have much say on this because our laser mainly come from either Germany or US. But I would say this, as a Chinese, I have faith in our national industry, and that's how we involve. So, and Maxeon is open to do trials with domestic laser supplier as well. So good luck, guys.
Okay, so then, it's my honor to have Dr. Wang, Dr. Xu, and Dr. Kopece, and Dr. Xu on the stage and join this panel. Thank you very much.